Okay. So as I said, we'll talk about um, statistics. Okay. So statistics is mainly of two types. Okay. One is your descriptive statistics. Other is your inferential statistics. Okay. Descriptive statistics talks about what has happened. Okay. So it's more about, you look at the data and you try to make sense out of it. What happened, how it happened. Okay. So in descriptive statistics, we take almost all the data. It's possible to get all the data and we perform analysis, right? So we'll see what kind of analysis we perform. We talk about inferential statistics, okay, which is not part of our discussion. Okay, we'll not be talking about it. So that is, it's as the name suggests, inference. You infer, okay. So you get the data, and based on data, you're trying to infer what might have happened. Okay, so inferential statistics is more of like, you take sample data and then you predict on that. For example, when you talk about election results, right? If you see, they'll have pre-poll discussion, post-poll, exit poll, things like that, right? So they will survey 10,000, 20,000 people, and based on they'll try to predict for 200K, 500K, a million people, right? So what they're trying to do is based on some sample data, they are trying to predict for the entire population, right? That is called inferential statistics. Okay. The concepts are more or less same, just that it is little, little different. Calculations are different. Okay. So in our syllabus, our focus is only on descriptive. Okay. Descriptive, you have access to almost all the data, right? It could be 100 rows or it could be 10 million rows. Okay. But you have access to all the data, right? Um, so what are the factors? Okay, but before we get into that, let's understand what is data set. How many types of data we have? Okay, so the data, okay, data can be numeric, okay, and it can be text, it can be categorical, okay, it can be time series. So mainly four high-level types of data we talk about. Okay, so first one we said is numeric. Okay, numeric data or quantitative data. Okay, these data have numbers. Okay, they are first numbers. You can add them, multiply them. Okay, you can perform all the mathematical operations. Those are called numeric data. Now, numeric data again can be discrete or continuous. Okay, so what does that mean? Discrete means, okay, the values will be fixed. Now, if I tell you, okay, how many um, pens you have, for example. So you will not tell me I have 5.5 pen, right? You'll tell me, you'll count and tell me. Now, when you count, it could be infinite or finite. In the sense, infinite means what? Infinite means very large value, right? Infinite means very large value, which is not possible to count. But still, if I ask you how many rice grains are there in 1 kg, right? Now, how many rice grains in 1 kg is infinite, right? It's very difficult to count, impossible to count. So we say infinite. But still, it is discrete because, the rice grain cannot be like 5.666, right? If you had all the time of the world, right? Or if you had a counting machine for counting rice grain, you can count and it would come to a discrete value, right? Like marks and things like that. They call it discrete values. Continuous values are, okay, as the name suggests, it is continuous. Okay, so when I ask you what is your weight, for example, okay, now your weight you would say 70 kg, 65 kg, 50 kg, 80 kg, whatever. But does it mean that exactly it is 80 kg? No, right? So I give this example, right? If you have these big weighing scales, right, where you weigh tons, and you take your gold jewelry there and try to weigh on that machine. What will be the weight that weighing machine will show you?
kg.
Yeah. So what will be shown on the weighing scale? When you put your earring, gold necklace on that machine, how much will be shown on the weighing scale?
Oh, 0.
You said kg, then where did you get point? Kg
Yes.
machine will not have point, right?
Um,
You have a weighing scale at your home,
yeah.
digital.
Yes.
How many decimal point does it show?
2.
2 decimal point. Okay,
Mm-hmm.
2 decimal point means you'll have kg, right? So it will definitely be less than more than gram. It will show. So you do tonight. You okay?
Yeah.
You
Yeah.
take your earring or necklace and put it on that weighing scale and see the weight. You try doing that. Okay.
Okay.
So you will get 0.00. I'm talking, I mean, if you have really 1 kg of gold, no, I'm talking about jewelry, right? Earring you won't wearing, you will not wear 1 kg of wearing jewelry, right? So
Mm.
if you put, okay, it'll show you 0, right? Okay. Now, does that mean that your jewelry has no weight? 0 kg, you will throw it away?
Yeah.
No, right? So, so weight means what we are approximating. So weight can be, okay, if you have 2 decimal places, weight will be shown up to 2 decimal places. If you had 5 decimal places, it would show up to 5 decimal places, isn't it? So the weight is such that, okay, if you do not, let's say, if you do not have any decimal place, then it will show you in kg, right? 70 kg, 68 kg, 69 kg, 72 kg. But if you have 1 decimal place, it'll tell you 69.8. If you have 2 decimal places, it'll show you 69.79. If you had one more decimal place, it'll show you. So weight is an example of continuous value, which is actually continuous. It can take any form. It's not very specific 80. No, it's not like, okay, you're 80, and if you got little more than 80, it becomes 81. No, right? It is not like that. Because weight is continuous, we are approximating it to 80, 81, right? Same way, temperature. Okay, you have ways to measure temperature. Now, let's say if temperature is 90, okay, and now you are saying it's 88 or 89, does it mean that it jumps from 90 to 89 or 891? No, it is continuous. Your thermometer that you are using to measure, okay, cannot measure 90.5. So once it is little more, it approximates to 91, isn't it? So what? So these data are values that can take any value. Okay, okay, it can take any decimal places. Okay, unlike number of grains. Number of grains, you will not say 5.66666, right? You will say 5 or 6 grains that you have in your hand, or okay, how many glasses of water did you drink today? Okay. But weight, temperature, these are metric that can take any value in reality. Our scales, okay, we design scales to measure it in a approximation form. But if you actually get down to measure, it will be very, um, it is not that easy to measure. Okay. So like for marks, for example, okay, when you write some exam, your teacher might give you, like 5, 6, or at max point, right? Teacher will not say, okay, for this question, I'll give you 3.33333 out of 5, right? So that is also discrete. Discrete means, okay, doesn't mean that decimal point is not there. It just means that you have finite value. Okay, it could be many, but still you have infinite. Sorry, it could be many, but still you have finite. But okay, but in terms of continuous, okay, it can take any value. So for example, you will not find anyone in this world with exact 70 kg. Not possible. So in this case, what we do, we take range. We take 69 to 70 kg. Okay, 69 to 70. So, your weight, if you want to be very precise, you can't be precise in this case. If you want to be very precise, you have to say My weight is 69 to 70 kg. Okay, my weight is so here we generally deal with range if you want to be very true, right? Time, right? Now, time also we say 6 a.m. Now, 6 a.m. is when hour, minutes, and seconds. Okay, hour is 6, minutes, seconds are 00, right? But does that mean that it is after 0 second it becomes 1 second? No, we are measuring. Okay, our scale is not able to measure. Okay, but if you look at stopwatch and some of those scientific watch, even in Python, if you take time, I think we have done it right. It gives you like 7 decimal places, 8 decimal places, isn't it? So those are continuous values. Okay, you cannot say after 6 it is 6 1. Okay, because between 6 and 6 1 also there is a lot of time. Okay, so it is continuous. There is a continuous. So the number you can add them. Okay, you can multiply them, subtract them, but they are uncountable. Okay, if you look at, so we approximate. Okay, so that's the difference between discrete data and your continuous data. Okay, so numerical data can be discrete or continuous in nature. Continuous can again be interval and ratio. Okay, interval and ratio. So what is difference between interval? Okay, data which is measured, okay, on scale, right? So temperature, for example, okay, okay, or time, for example. So we have designed a scale to measure them, right? So you say, okay, temperature is 20 degree or 31 degree or 25 degree or 80 degree, right? Okay, so there is a scale and then you are approximating based on the scale. So you are approximating based on the scale. So that's called interval data. Okay, you don't have see, you cannot have continuous values, so you create interval. Okay, that means if you reach weight, for example, okay, if somebody asks you to write weight, you will not say my weight is 70.65, right? So okay, so if it is 70.1, you will say 70 kg. If it is 70.6, you are saying 71 kg, right? So you are looking at the interval and based on that you are measuring, right? That's why you have this. What is decimal point? That is interval only, right? Ratios are based on something by something. Okay, like half, 1/4. Okay, so let's say, okay, if you see here, okay, this is interval data. Okay, what is this? This is let's say collection of or companies revenue. Okay, now revenue may not be a good example because revenue, okay, cannot be continuous. But let's say if you talk about temperature, right? You are measuring the temperature, daily temperature, right? So when you measure daily temperature, that would be a interval data. Ratio is when you take percentage or you take ratio, something by something. Okay. So this is one example where you are trying to ask students their age and what they want to buy. Okay. So see, most of the people want to buy laptop. So you can say that, okay, in age group 20 to 25, most of the people wants to buy laptops. But above 40, okay, most of the people wants to buy digital camera. Okay, you see how that it is changing based on age. Now, this is what we call as ratio. It is percentage. We tell something with respect to something. Okay, 30% people wants this, 20% people wants this, 10% people said this. Okay, so in terms of numeric data, you have discrete, continuous. Continuous can again be your ratio or interval. Okay, one of the important plot that we draw, okay, when data is continuous, okay, is called scatter plot or numeric. Okay, need not be even for discrete also you can draw. It's called scatter plot. So scatter plot is always, okay, let me show you this. So let's say I want to analyze the performance of, let's say what happens, okay, if you study, let's say this is your study hours in study. How many hours you study, right? So this is your hours. And this is your marks. Now everyone, this axis is called which axis? This one, marks, is on which axis?
Y-axis.
This is your y-axis. Yes, this is called y-axis. Okay, and this is your x-axis. Okay, so what happens, you actually can divide the plane into 4 parts. You divide the plane into 4 parts. Okay, horizontal line is called x-axis. Horizontal line, is called x-axis, x. And this vertical line is called y-axis. Okay, so you're dividing the plane into 4 parts. This is called, this is called first quadrant. First quarter. No, first quadrant. Quadrant. Okay, this is your second quadrant. Okay, this is your third quadrant. And this is your fourth quadrant. Okay, now values here on right side, x value will be, so this is where they meet, is origin. This is called origin, and you'll have 0, 0. This is 0. So first we write x value, then we write y value. So x is 0, y is 0. So this is 0, 0, x 0, y 0. Okay. Now from here upward, y increases, downward, y decreases. So this could be, let's say 5, 10, 15, 20, 25, so on. So these are your positive y values. And downward, you will have negative y values. Okay, minus 5, minus 10, minus 15, minus, 20, 25, so on. Right? It goes up to all the way up to infinity. Here also goes all the way up to infinity. This side, you have plus x. So 5, 10, 15, so on. This is your plus x. Right? And this side is minus x. Okay. So if I say 5 comma 6, what does that mean? It means 5 on x-axis, 6 on y-axis. So this is 5. So this entire thing is 5. X is 5. Okay. This entire thing is y equal to 5. So I wanted 6, right? So 6 will be somewhere here. So this is your 5 comma 6. 6 comma 5. 6 means x-axis. So somewhere here, and it will be on this side. So this is your 6 comma 5. Right? Similarly, minus 6 comma 5. Minus 6 is x is minus 6. So let's say if this is minus 5, minus 6 will be somewhere here. And I said plus 5. So plus 5 is upward, right? So this is your minus 6 and plus 5. Minus 6 minus 5. Both are negative. This is where both are negative, right? So x-axis minus 6. So minus 6 and 5 here. Minus 5, minus 6. You get somewhere here, this point. Okay. Now here,
Yes.
yeah, x is plus and y is minus. Okay. Now you tell me, in quadrant 1, x will be plus or minus?
X will be plus.
X will
X
be
and
plus.
Y both are plus.
Yes, first quadrant, x and y both are plus. On second quadrant?
X plus, Y
X positive, Y negative.
minus,
No.
Y X minus,
Sorry.
plus
X negative, y
Y
positive.
positive. Yeah.
Right? It is still upward, first half, northern hemisphere. Okay. Okay, upward part. So upward means y. So y is positive, x is negative. Third quadrant?
both negative.
Both are
Both
negative.
negative, correct. Fourth quadrant?
Y negative, X positive.
Correct. Y negative, x positive. Okay. But see, in data analysis, mostly we'll come across positive numbers. Okay. So we deal with first quadrant only. Okay. I mean, I can't think of any situation where we'll deal with negative quadrant. Okay. It will be positive quadrant only. So what I have drawn here is positive. I've taken this one and taken only this part. Okay. I have taken the first quadrant only. So what you see here is first quadrant. Okay. Okay. So let's say this is number of hours you study and marks you obtain. Now in mathematics, if you see generally, we write, okay, y equal to ax, ax squares, or bx, something like this, right? This is how we write. Always, okay, notation. It's not mandatory, right? But generally we write y on left side, okay, and x on right side, correct? Now, to find y value, you need to know x value, isn't it? Generally, they'll say what is value of x, y, given x is so much. So x is something which is given. X is something that we, okay, is what we generally know, or it's in our hand. But y is not in our hand. Okay, y will change based on the value of a and x. Correct? The y value will change based on x and x value, x, a, b, c. So in a way, if you see, we are not controlling y, we are controlling x. X is in our hand, but y is not in our hand. Okay. So what it says is, okay, if, okay, so here x is not dependent on y, but y is dependent on x. That's why x is also called as independent parameter, independent variable. X is called as independent variable because x is not dependent on anything. Okay. Okay. Y is dependent. Y value will change based on x and a and b and c. Generally, a, b, and c are constant. Okay. We call them as constant. Okay. They don't change. Okay. They'll have a fixed value for a, b, c. X is variable. That's how we write notation, right? So we say x will change, a, b, c is constant, and y is dependent on a, b, c, and x. So y is called dependent variable. Y is called dependent variable, and x is called independent variable. Okay, x is your independent variable, y is dependent variable. Now, on the right side, you can have more than one variable, but left side, you'll have only one. Okay, you'll always say y equal to, and you can have many variables on the right side, correct? So generally, okay, you'll have only one dependent variable, okay, only one, but you can have multiple independent variable, right? Okay, but we are not going there yet. Okay, we'll talk about only one. Okay, so what we do is, okay, this y value we write on y-axis, we represent on y-axis, x value we represent on x value. Now tell me, between marks and hours, okay, between marks and hours to study, okay, which is y and which is x? Which is dependent, which is independent?
X is independent.
That's what I told you. X is independent, but I'm asking about marks and hours. I asked you x and y. I told you x is independent, y is dependent on x. But I'm asking you in hours and marks, which is independent, which is dependent?
Hours is independent.
Marks is independent.
Yeah, hours.
Okay. And hours of study?
Hours is hours of study.
That is dependent.
No, marks is dependent.
Marks is dependent.
Hours is independent.
Hours is independent.
Independent, right?
Right? So yes, I have put that, right? Hours on x-axis. So correct. Hours is independent and marks is dependent on hours. Now, why do you think hours is independent and marks is dependent?
Um,
Yes. So
Depending
see,
on how much time you spend, marks.
correct. Okay. So now you see here, what we are saying is ours is independent because we can choose to do whatever we want to do with ours. If you don't feel like studying, don't study. If you feel like studying 10 hours, you can study for 10 hours. Correct? So you can control this hours. It is, not control in the sense it's up to you. That's why it's independent. Nobody's questioning you, right? You can choose what you want to do. But marks is not independent. If marks were independent, okay, it can get whatever value, then nobody would prepare for the exam. See, when do you prepare? Why do you write so well in the exam? Why are you so scared about the exam? Why are you so scared about interviews? Because in interview, if you perform well, we get selected. If you don't perform well, we don't get selected. If interviews were independent, that means what? Whatever you do, you cannot control. So if whatever you do and you cannot control interview, then nobody will be scared. Nobody will, it's as good as doing a lottery system, right? Okay, 10 candidates, okay, pick one, and right, not that. So there are factors based on which marks are dependent. There are some factors based on which, the weather, the climate change is dependent on some factors, right? So these are factors which are dependent. Okay, so if I want to control, I can't control marks. Okay, everybody wants 100%. Everybody wants to clear the first interview itself, but it's not in our hand, right? So what is in our hand? Our hand is in preparation. How many hours you give to preparation, right? Now, so that's how, see, you can put hours also on y-axis, marks also on x-axis. In terms of visualization, in terms of data, you won't get any difference. Okay, but okay, this is the notation. Okay, so when you perform your analysis, just make sure which one should be on x-axis, which should be on y-axis. Okay, you should do not randomly, you should do like a learned person who understands what x-axis and y-axis. Okay, so something that is caused by something else should be on y-axis. Things which are independent is not influenced by anything else, okay, is on x-axis. Hours of study, up to you, right? Okay, so that is on x-axis, but marks is dependent. How many hours you study, how well you write. Okay, I'm just taking one factor. That's what I'm saying. Independent factors can be many. Okay, independent factors is not just one. There can be many, but dependent factor is only one. Okay, marks is the dependent factor, but marks can depend upon many other parameters: number of hours you study, number of hours you sleep, number of hours you eat, number of hours, so many things, right? I'm talking about number of hours. It's also about what IQ level, many other parameters, isn't it? So we are taking just one of those parameter, which is number of hours you study. Okay, so okay, and now you know which one to go on x-axis, which one to go on y-axis. So when you plot your graph, whether it is Python or Tableau or Power BI or Excel, you know which one to go on x-axis, which one to go on y-axis. Yes or no? Okay. Now, in terms of visualization, in terms of what you see, it doesn't mix. Anything is fine. Okay, but this is what there's some messages which goes, right. There's some messages which are unspoken also, right? We look at the body language. So this is the body language of graph. The graph that you see is what they speak, but body language of graph is this. These things are important. Okay, it shows that okay, you are experienced, you know what you are doing. Okay, randomly doing, okay, doesn't make sense. Understand? So this is okay. The moment you start talking about this, okay, before I could plot, when you do like this, hours and marks, the interviewer or your team will know, oh, this fellow knows what it should be. Okay, so this is how you represent metric on x-axis and y-axis. Now we're talking about a scatter plot. Scatter plot is xy plot, we say. Xy plot means there's one value which will represent x. When I say 5,6, right? So let's say this is your 5,6. Okay, this is, let's say, 6,8. This is, let's say, 7,9. Okay, so you are drawing multiple points here on this graph. Each point is representing x-axis as well as y-axis. So each point is representing hours and marks. Okay, so let's say if this is 5, let's say, and let's say this is 40. It's possible, right? So it means, this particular student, this particular row of data has value of 5 on X and value of 40 on Y. Correct? Metric may not be same. Here you can have metric 1, 2, 3, 4 to 24. Let's say this is hours per week. So 40, right? So this could be metric, up to 40, and this could be metric up to 0 to 100. Okay, so they'll not be same, but when you do this, it should be equal. So if I say this is 10, so same distance should be 10. Let's say if this is 1 centimeter, that's why we use graph paper. If this is 1 centimeter, this also has to be 1 centimeter, 1 centimeter, 1 centimeter. Okay, so 10, 20, 30, 40, 50, 60, so on. And if this is 5, let's say you're measuring 1, 2, 3, 4, 5. So 6, 7, 8, 9, 10. Okay, so like that. So this represents data on, two data. So number of hours this student has studied, one row of data, right? So in one row you have taken 2 column, which is hours and marks. So this is 5 hours and 40 marks. This is, let's say, 9 hours and 60 marks. Okay, so 9 comma 60. This is how you write, right? First X value, then Y value. This is 9 comma 60. This is 5 comma 40. This is, let's say, 15 comma 80. Okay, this is 20 comma 85. Okay, this is 30 comma 95. Okay, so this is a point that is representing the given data. So this student studied for 5 hours, got 40 marks. This student studied for 9 hours, got 60 marks. This student studied for 15 hours, got 80 marks. Studied for 30 hours and got 85 marks. Studied for 35 hours, what was 20? Sorry, not 30. Okay, 20 hours and got 85. Studied 30 hours, got 95. Right? So this is how we represent scatter plot. Scatter plot represents value on X and Y. Each row of data is represented on 2 columns. Now we're talking about plot which is 2-dimensional. Okay, we'll be drawing 2-dimensional plot only. So at any point of time, you will have only one data, right? So bar graph, okay, we'll learn all those things one by one. So you're taking only maximum, I think you're taking is 2. Now there is way to take 3 and represent in 2-dimensional only. So we'll talk about those. But right now our focus is to know this 2-dimensional graph. Yes? So scatter plot is plot, okay, we use when you have numeric data, okay, or quantitative data. It could be discrete or continuous, doesn't matter. Okay, doesn't matter whether it's continuous or discrete. Hours, okay, is continuous if you see time, okay, and marks is discrete, right? But doesn't matter, okay, numeric. Okay, so remember, right, when you have numeric data to visualize, scatter plot is the best way to do that. Okay, any questions so far on this? Okay, so later we'll see how to analyze and what message we get from here. Let's go back to our notes. Okay, so this is a scatter plot. Okay, so same hours per week and grades scored, right? So this is same example we took. So if you see here, this fellow, okay, studied for only 5 hours, got only 10 marks or something, right? Now this is studied for very less and got very high marks. Okay, so so it's not only hours that affect, right? There could be other factors also. This guy's IQ level is very high, let's say. Okay, this fellow's IQ is very high. If he studies only once, he's able to remember, right? So he doesn't need to spend more time on studies. But if you see, most of the values will be around average. There would be some outliers. There will be some outliers. Outliers means, okay, so value which is not in line with most of the values. Okay, so let's say there could be, right, in your office, at your in your class, in your family. Okay, everybody is like average. 1 or 2 people are too brilliant, or 1 or 2 people are very less, right? They are not even up to the standard, right? So there could be outliers on both the side. Okay, it could be on the higher side also, the lower side also. Okay, so we call in terms of biology, we call it as regression. Okay, and what does it mean is, so they say this example. Okay, let's say 5,000 years back. Okay, there would have been somebody with height 6 feet, 7 feet, possible or not? Yes, 5,000 years back, we would have had a human being with 6 feet, 6.5 feet, 7 feet, possible or
Yes.
not? Yes, possible, right? Now, what do we say? Somebody who's tall, we expect the children to be tall, correct?
Correct.
Right? So, if 5,000 years back, if one person was 7 feet, his or her children would have been 7.1 inch, based on our analysis that tall people will always have tall children. Then their children 7.1, their children would have been 7.2 inch, their children would have been 7.3 inch. 5,000 years, same family, if you look at, we would have had somebody with 10 feet today, 12 feet today. Do you
No.
see anybody with 12 feet?
No.
No. So that's why it's biology or nature is like that. Okay, it does not work like that. So most of the things is average. There will be some exception. If the average height is, let's say, 5'8" or 5'9" for Indians, okay, average you expect 5.9 only. If somebody is 6 or 6.5, it is an outlier. So don't expect the children to be taller. Okay. If somebody is short, okay, that is an outlier. Don't expect the children to be short, because nature always plays with average. Okay. Nature always plays with average. You may be exception. Okay. But doesn't mean that, then Einstein's children would have been super, super smart, right? And then the Einstein's grandchildren would have been super duper smart. But it's not like that, isn't it? So Einstein was an exception. Okay, everybody in the family, okay, would be average. Okay, just because one person became outlier doesn't mean that everybody can become outlier. Okay, so what you see here, this high point and this low point, these are exceptions. We cannot base our decision on these 1 or 2 points. Okay, now rest of the point you see, they are average. They are behaving like same, like as you marks increases, sorry, hours increases, marks increases, right? So this is what we should be based on our analysis. Outliers possible, okay, not that data is wrong, it is possible, but those are rare. Those are rare. See, so if you have Virat Kohli, do you expect him to score 100 every match, right? Not possible. Okay, if you scored 100 today, definitely is going to score 0 in next 5 matches. Okay, that is nature. Okay, okay, and the biology was the first subject that used these concepts long time back, 200 years back, 300 years back. In computer science, in engineering, we are reading now, because now we have computer, we can analyze a lot of data. But biologists, okay, were the first one to, and a lot of application also, if you see, of data analytics is used in biology only. All these analysis of, cancer research and any new medicine, they do a lot of research. Okay, we are studying about analysis now because we have computer and which can process a lot of data. Okay, so this is in fashion for last 10, 15 years, 20 years maybe. Okay, not even 20 years in our field. But in biology, it's been used for hundreds of years. Some of these concepts were designed hundreds of years back. Okay. Okay. So coming back to our discussion, these are your numerical data. Okay. Numerical data, okay, is about numbers. Okay. It can be finite, infinite, countable, non-uncountable. Doesn't matter. It's all the same. So we now know what is continuous and what is discrete. In continuous, you can have interval or ratio data. Okay. Ratio is where you say with respect to something, right? There's denominator. And when you have a scale, we say interval data, right? Like grade is an interval data. Okay. Your number of people wanting to buy something. Okay. It is a ratio data. Okay. But all belongs to, okay, continuous. Okay. Second type of data is called categorical data, or sometimes we also call it as qualitative data. Okay. These are not numbers. They are about category. So the answer or the value that you're going to get will be among a category. Okay. Number of marks that is obtained can be anything, isn't it? Can be 0 also, can be 100 also. But in categorical, answer will be among the given value. So if I ask you to rate my training, so when you say rate my training, I'll give you scale from 1 to 5, right? So you cannot say 10 on 5, or you cannot say -5 on 5. Okay. Answer given to you is 1, 2, 3, 4, 5. So, I'm not going to get less than 1. I'm not going to get more than 5, right? So that's the score. So here our score is given, output is given, and the actual answer is going to be one of the given values. Okay. So here you see you have poor, fair, good, very good, excellent, right? So you cannot say that, I want something between very good and excellent. No, you have to choose very good or excellent. You cannot say something in between that. Okay. So it's called categorical value. Categorical values will have a set of values, and the output, the result is going to be one of the given value. So there are two types of data in categorical. One is called nominal, another is called ordinal. Nominal is where order doesn't matter, like male, female. Now, when I say male or female, or I say male or female, or female or male, doesn't really matter, right? Whether you put female first or male later, or male first, female later, doesn't matter. Region, north, south, east, west, doesn't matter which order you tell them. Okay. Manufacturers of car, doesn't matter which order you tell them. Okay. These are called nominal. They are only to nominate, or they are only to represent that category. Okay. They are there to represent that category of information. Ordinal is where order is important. Okay, the scale, right? We say course rating, right? So course rating, I cannot say, okay, rate me 5 is very poor, 4 is excellent. You can't say that, right? 5 is very poor, 4 is excellent, 3 is average, or maybe 1 is average, 2 is poor, 3 is no, right? The order has to maintain. Either you say poor to excellent or excellent to poor, right? But it has to be in order, right? Grade A, B, C, D. You don't say A is like less than 50% and B is like more than 90%. No, you can't say like that, right? So either you say A to E or E to A, right? Preference, first, second, third choice. So these are categories where order is important, and when you write them, it will be in specific order. Okay. Now this is called categorical because both data, if you see nominal and ordinal, they are to represent your expectation, right? What do you think, or what do you rate, or what do you have got, right? So okay, so it's possible that that somebody who has scored highest on B grade and somebody has scored lowest on A grade, the difference could be just 1 mark, right? So within 1 mark, they have got 2 different grades. And which has got lowest on B grade and highest on A grade, the difference will be, let's say, 20 marks, right? So you cannot say that, that B people are 30% less smart than A. Okay, it just happened that there are some people in A which are, because of the cutoff, they made it like that. Right? You cannot actually say that this is 10% or 5%. Okay? It is just to represent. Okay? So both are representing. Right? So you cannot say that when you say excellent, that means that excellent is 3 times of very good. Okay? And very good is 3 times of good. No. It just means, what you think where the rating is. Correct? So you cannot, when you see this order, it is again a nomination in a way it's nominal in a fixed order, right? You cannot say that it is 5 times, 10 times, or 2 times. Okay, so you have categorical data. Categorical data can be nominal or ordinal. Okay, so for nominal data, okay, we use something called as frequency table. Okay, we use frequency table. So let's say there's a this talks about data where there's a college data, and these are the placements that college have provided. So there are 253 students, and they got placement in accounting, finance, general management, marketing, sales, and others. So 73 people got placed in accounting, 52 in finance, 36 in general management, 64 in marketing, 28 in other field. Okay. So how do you represent? So see, accounting, finance, general management, these are your categorical data. And very specific, these are your nominal data, nominal categorical data, right? Because there is no order of that what you write first. Okay, so you can choose your own order, like alphabetical order or number with based on number of people, highest will go first, right? You can choose your order, but this order doesn't indicate that okay, accounting is super best, okay, and others is not so best, right? So you write them in an order, okay, and then we figure out how many of them are there in that category, how many values are represented in that category, right? So you say the accounting is about 29%. So pie chart is an example of representing your categorical value, right? Okay, you cannot draw a pie chart of marks that is obtained, okay, or number of hours that you studied. No, you can convert it. Number of hours you study, you can say 0 to 5, 5 to, or 0 to 10, 10 to 20, 20 to 30, 30 to 40. So you are converting a numeric data into categorical data, which is possible, right? What is grade? Grade is, okay, we are converting average into, so average is your numeric data, quantitative data, we are converting that into grade, right? So you are creating a range, okay, so you are converting a numeric data into a categorical data. But you cannot represent numeric data as a pie chart. Numeric data can be anything, right? So not possible to represent that on a pie chart. So pie chart is one good example for representing categorical data. Histogram. Okay, so we'll talk about what is histogram tomorrow. Histogram looks at the frequency, okay, occurrence, how many occurrence, okay, and on x-axis we represent those, like those are nominals, okay. On x-axis we represent the group or grade. On y-axis, we represent the count, how many. So y-axis is always about how many, and x-axis is about those category, okay, category of information. So important graph that we plot for categorical values are your histogram. So tomorrow we look at what is histogram, what is significance of histogram, okay. So we'll talk about it. Any questions before we wrap up? I'm going to share this link, okay? So you can go through this document. I'm not going to get through the details, right? Like this, okay? And then you have two more types of data, okay? One is called time series data and text data. Time series data is like numeric data, it's quantitative data, but there is a timeline that is associated, okay? So timelines that is associated, okay? Now, if I ask you what is the revenue of a company, so revenue of a company will ask me, talking about daily revenue or weekly revenue or monthly or quarterly or annual revenue. So you cannot just say number, you have to have a time component associated. Okay, time component associates, when you associate time component, becomes time series data. Okay, how many people fly? So you ask me, how many people fly every day, every hour, or every year? So there's a time component that is associated. In 1966, so many people traveled. Okay, in January, that was the revenue. And February, this was revenue. So you have February and then the revenue. So you have a time component and then the number. Okay, so when you have time component and the number, okay, it is called time series data. Okay, and then the fourth type is text data, normal string, what you say in Python, right? Text. Okay, now you're analyzing Twitter data. Analyzing Twitter data is analyzing text data. You can't perform addition, subtraction, you can't group them. But after analyzing, you can group them, right? So let's say I want to look at the Twitter data, Twitter messages, and I want to classify each of them as either positive or negative, or maybe positive, negative, or neutral. We call them sentiments. Okay, so when somebody says, "Oh, we have won today, we won the match," okay, so it is a positive tweet, right? So we'll classify it as a positive sentiment. Okay, we will launch more rockets on that country. Now that's a negative. So we say that's a negative trend, negative sentiment. It could be positive sentiment. I ate food today. I slept today. I played cricket today. Okay, it could be neutral. It doesn't say either positive or negative. So it could be neutral sentiment. So you look at the text data, you analyze the entire tweet, and based on that, you are coming up with So your Y in this case is categorical. Y in this case is categorical. Okay, you are converting the entire input data. X is numeric text, not numeric text. X is text, right? X is the input, which is your entire. How many characters they have? 230, 232, right? I don't know, right? Those many characters are your input, right? And then you are converting that X into Y. So Y can be categorical. So most of the time when you talk about Y will be either numeric or categorical. Okay, most of the time. Input X can be your text, categorical, number, or text. Text, time series, categorical, or number. So X can be any of these four. Y, 99% of the time it's going to be, okay, your numeric or categorical. Okay, and numeric also very less, mostly is going to be categorical, right? Numeric, you will get Y only if X is also numeric. But moment X becomes something else, as X becomes text or time series or categorical, Y also becomes categorical. Okay, you cannot get numeric data from text. I'm talking about analysis. I'm not talking about simple mathematics. I can say number of tweets or number of characters, but that is not analysis, right? That's not what we want to analyze. We want to analyze whether it is talking about positive or negative. Let's say you are a company, right? You launched a product, okay, and you want to see what are people talking about your product. Are they liking it, not liking it? Movie, right? Somebody releases a movie. They want to see, are people happy about the trailer or not happy about the trailer? Okay, that would be one input for them to know how well the trailer is, right? One thing is look at the number of views. That is one parameter. But after views, what is the comment? Are they liking it, not liking it, right? So okay, so when we analyze, mostly what we analyze is either numeric or categorical. So let's say the data could be a video also. Okay, you look at say movies data. Okay, you watch a movie, okay, and after 2 hours you have to rate it good or bad, right? So your input data is a video file, right? But output is yes or no, liked it or not liked it. So Y can still be simple categorical, right? But input can be anything, can be text, PDF, audio, video, right? They classify your movies as genre, right? Or audio songs as genre, right? Pop, classical, right? So we classify them. So input data can be anything. Okay, output is mostly simple and something that it's easy to do that. Okay, so most of the work that we'll do, okay, in visualization is mostly around numeric and categorical. Okay, it's mostly around numeric only, right? But okay, you can even perform text and time series data. Okay, so tomorrow we'll see how to analyze categorical data using histogram. And then we'll look about the statistical metric, which metric we use in statistics.